Okay, so now we're actually going to solve this, and we're going to write the partial fraction decomposition. All right, so we're going to do like we did on the first four. We need to rewrite this. So this denominator, I can factor out an x, and that gives me a 3x plus 1. Okay, and then the right-hand side then, we'll have some constant here over x, and then plus some constant here. And these will just be constants because these denominators are linear terms, okay? In other words, they have exponents of 1. All right, now, so at this point, what you do is you get rid of all the fractions, and you do that by multiplying everything by the least common denominator, all right? And the least common denominator is simply the two denominators multiplied together. So over here, that's really, really clean. I'm going to multiply by x times 3x plus 1. That's just going to give you with 1, leave you with 1. Now this gets really cool. So this is going to be x times 3x plus 1 here. Okay, and this will be x times 3x plus 1 here. And you're like, this is terrible. We've got variables all over the place, and we got a's and b's and stuff. But watch how it all falls into place. It's pretty cool. All right, so on the left-hand side then, that's just 1. Okay. All right, now watch this. On the right-hand side, these x's cancel. All right, and I'm left with this. I'm left with 3a times x, okay, plus, I'm distributing right here, plus a, and then over here, on the right-hand fraction, the 3x plus 1's cancel, and I just have b times x. All right, now, here's the deal, and here's the way this works. All right, so everything that has an x on this side has to equal everything that has an x on this side. But you're like, there's not any. That's true. All right, this one actually is a pretty cool one. All right, so that means that these two have to equal that. Well, then I can just ignore the x's. All right, so they all have x's. So this 3a plus b has got to equal 0. So just kind of ignore the x's. So 3a plus b is going to have to equal the number of x's that I had on the left-hand side, which is 0. And then this really falls into place because now a is 1. So a is 1. So I've got a system sort of. In this case, I really don't have to do a matrix or a graph or anything because, I mean, I know a is 1. So if a is 1, I could go ahead and say that right there. But if a is 1, I can go to this top equation and substitute. So 3 times 1 plus b is supposed to equal 0. Okay, well, that's -3 then. So b is -3. All right, you know what that means? Here's the fraction decomposition. A is 1. So here's my answer. So it's going to be 1 over x, okay, plus, and then b is -3. So you could put -3 there if you want to, but this will be fine. So -3, and that's over 3x plus 1. You're like, why would I ever want to do this? Well, because there are times in calculus, and this is algebra for calculus, where we're going to want these fractions to be separate. We want that fraction to be broken into two different fractions, okay? So that's it. So that's it for number 5.